Okay, good afternoon, everyone. Today it's going to be a quick lesson, mere 20 minutes or so, on how to find the area of a triangle, but not using our old standard area equals 1/2 base times height. In fact, these are one of the few formulas where you don't actually need a perpendicular to find the area. Okay? So the first formula I call the area of a triangle is the side angle side area formula. All right? Where again I'm given two sides and the angle in the middle of a triangle to find the area. Okay? So let's start with drawing a triangle out. Just any old triangle. Let's go with a little bit of a, that's not a very good triangle. Let's try to undo that and draw it again. Ready? 1, 2, 3, and there we go. So I've got what looks to be an acute triangle here. The side angle side area formula says that if I'm given two sides in a triangle, say A and B, and the angle in the middle, say C, then the area of this triangle can be found using the formula area equals 1/2 A times B, where A and B are your sides, times the sine of angle C, where C is the angle in the middle, or as we like to say in the business, the included angle. Okay? So, let's take a look at this. Let's take a look at an example of what I'm talking about. Suppose I'm given this picture right here, and it doesn't have to be on those two sides. It can be anywhere. In fact, watch me. I'll do it. Yeah, I'll watch me. Suppose this is, say, 8 and this is 11, and say this angle, say, 72 degrees here, right? Well, to find the area of this triangle, all I have to do is say the area equals 1/2 A times B, which is 11, times the sine of the included angle, 72 degrees, right? Well, all I have to do is cut that into my calculator now. All right, so I go 0.5. Since I'm talking about decimals here, might as well stay with decimals. Or actually, I don't have a decimal there, so 1/2 times 8 times 11 times the cosine. That's right, sine of 72 degrees. All right, a little bit of enter. So the area of this guy is simply 111. I'm sorry, 11.17 say units squared. Okay. So now, hey, guess what? We have a guest speaker in here. Everyone, I'll tell you what. If anybody can identify this voice, I'll give you some piece of candy or something. Say hello.
Hello, Mr. Khan. How are you?
I'm very good, nameless person.
Just, passing by.
Good. All right, so if you can identify that voice on Monday, first person in each class, I'll give you some type of prize. Okay, so now let's take a look at another example. Let's get rid of all this rigmarole. And let's do one more like this. And you're like, but Mr. Khan, this is so easy. Do we really need to do another example? Well, let's just for fun, suppose I gave a problem that looked like this. Suppose I told you that this was, say, just for fun, 91 degrees. This side was, say, 12 this side, this time. And this side right here was 14. Okay? Well, as it stands, this formula is called the side angle side area formula for a reason. I have to know two sides and the angle in the middle. This 91 degrees, he's not in the middle. If it was like this, all hunky-dory, we'd be ready to go. But it's not. He's over here. In fact, this looks like an angle side-side scenario. So does that mean there's two triangles possible? Well, typically you would say yes. But we know, since this angle is 91 degrees, and this is 14, I know there's only going to be one triangle possible here. Because my obtuse angle, and that's where the ambiguity comes in, my obtuse angle has already been established, okay? All right, so to find this area, I need to find either this missing side here or this missing angle here, all right? Now, I know that I have three numbers in this triangle, one of which is the side, so I know I can find whatever I want. So let's just go through this and solve for this, either this angle or this side, whichever comes first, all right? So, to make my life easier, I'm going to call these angle A, B, and C, just so I have a point of reference. And I want to say, all right, the sine of 91 degrees over 14 equals the sine of C over 12. I have to find that angle first, okay? All right, so now I type that in. You know how to do that. All right, when we do that, we get C equals, rounded to 1 decimal place, 60 degrees, right? Oh, that's nice and easy, right? So this angle C is 60 degrees. Oh, wait a minute. Now I know that if this is 91 and that's 60, I can find this angle right here. Wouldn't that be 151 when you add it together? So that has to be 29 degrees, okay? Well, wait a minute. So I've quickly found the side angle side that I need to find the area. And I get the area equals 1/2 of 12 times 14 times the sine of 29 degrees, okay? And I input that into my calculator. And I get the area to be 40.7 square units, okay? So there's one where we have to find the area, but we had to do a little bit of work before we could go straight to this simple formula. I had to find this missing angle first, okay? All right, ladies and gentlemen, now the next problem is based off of knowing all 3 sides, okay? This is the side area formula. And it was actually developed by a guy named Little Johnny Heron. Okay? And here's what it says. It says the area of any triangle can be found by taking the square root of s times s minus a times s minus b times s minus c, where A, B, and C are the 3 sides of my triangle, and S is the semi-perimeter. And we get semi means half. So S would equal, if it's half of the perimeter, how do you find a perimeter of a triangle? You add the 3 sides together and you divide by 2. Okay? So, now let's take a look at where I'd have to use this. And again, I would only ever use this formula because it's ugly. I'd only ever use this formula if I'm given a triangle where I know all 3 sides. So let's do a triangle. You know what? Let's not ignore our friendly obtuse triangle. He often is overlooked. So let's do one here. Ready? Suppose this side is, say, 11. This side is 14, and this side right here is 20. Can I make it 26? Can I make it 26? Could I make it 25? No, I can't. That's right. 24. Let's make it 24. You think about why I can't make it a 26 or a 25 for all you SAT takers coming up. All right. So I know the formula is the area of a triangle is equal to the square root of s times s minus a times s minus b times s minus c. I need to figure out what s is. So s equals 11 plus 14 plus 24 divided by 2. So you get that. You get 49 divided by 2 is 24.5. Is that correct? I hope. So that's by semi-perimeter. So the area is simply the square root of 24.5 times 24.5 minus the first side. And it doesn't matter which side you use, say 24, times 24.5 minus the second side, which is, say, 14, minus 24.5, or times 24.5 minus the third side, which is 11. Okay? Okay. All right, now let's just type this guy in. So the square root of the semi-perimeter is 24.5, parenthesis 24.5 minus 24, 24.5 minus 14, and 24.5 minus 11. Okay? All right, so by doing that, I get a total area of 41.7 square units. So the area of this guy is, in my poor memory, I don't remember what I said, 41.7 square units. 41.7 square units, okay? And again, all you have to know is all 3 sides of that to find that. Well, unfortunately, this screencast is under 10 minutes. So if I give it a dramatic pause, maybe we can make it an even 10. Actually, guys, there's a mistake, a mathematical mistake on this. If you can find that mistake, first person to give it to me, I'll give you 1 bonus point on the quiz on the test coming up. Okay? So anyway, this is exactly 10 minutes right.